Hello guys, welcome to my YouTube channel Code Station. Today we are going to discuss graph related questions that are most likely to come in interviews of Amazon, Google, Facebook, Microsoft, etc. So the first question that we are going to do is DFS of a graph. Uh, the question is from Geek for Geeks and we just have to make the main logic here. So here is the question and here we have to write a code. Okay. So we have to use recursive approach here. The input is given as pairs of u and v, denoting that there is edge from u to v. Okay, so 0, 1 denotes that there is edge between 0 and 1, 0, 2 denotes that there is edge between 0 and 2, and so on. Here is the explanation. 0 is connected to 1, 2, and 3. 0 is connected to 1, 2, and 3. Okay. 1 is connected to 0. 1 is connected to 0. Okay, so obviously, if 0 is connected to 1, 1 is obviously connected to 0. So, and so on. So the DFS from 0 will be 0, 1, 2, 4, 3. Okay, so the main idea behind DFS of a graph is that we traverse the graph node by node, visiting only the adjacent node to the last visited node. So the problem that comes in graph is that we might have loop inside it or a cycle inside a graph which we may traverse infinitely many times. So to overcome that, we just make a boolean vector or boolean array of visited and we mark the visited nodes inside that array so that we don't visit them again. So that's the main idea. So let's start coding it. First we have to make oh so the boolean visited array is already passed inside the function and they've already made us uh, the whole boolean visited array and marked all the nodes as false, that they have not been visited yet, and the adjacency list is made here. The name of the list is G. Okay, and what else has been passed? So the source has been passed, that is 0, and that is the node. Okay, so everything is already made here, we just have to write the main logic. So we first mark the uh, zeroth or the source of the graph as visited. Then we print its value. Cout, we are doing in C++ here. Now what I have to do is just reverse for auto v is equal to 0, v is less than oh, so since this is adjacency list, we need to reverse it like a list. So g s dot begin v not equal to gs dot end v plus plus if the node is not visited, we just recursively call the DFS function on it. Then G and this. Okay, so if this is the case, then this must be the disconnected graph. Oh, the connected graph. In case of disconnected graph, we will have to make another function and like run a loop inside it to check this DFS function for each node in case of disconnected graph. So this right here we have only the connected graph, so we are doing DFS on a connected graph only. So if we run for sample case, let's see, is everything okay? No. Run code 012430123. What's the sum? 012430123. So this looks okay. uh, let's submit. Okay, so in DFS, since we need to traverse node by node and visit the adjacent nodes only, we need a stack data structure for it. But we only need to make that stack manually if we are doing it iteratively. In case of recursive function, we are making use of function call stack that this function is building with each recursive call that it makes. So that's it. This is the code right here. In case of any doubts, you can just comment down there in the comment section, and see you in the next video. Please like and subscribe.